So in part one, I showed that the reaction between this diene over here and the dienophile would result in a potentially 8 different products based on stereochemistry, regioselectivity, and whatnot. So we have to look at the endo-exo rule, the regioselectivity, to figure out which product is actually the major product. In this video, I'm going to talk about the regioselectivity. In order to do that, you need to look at the electronic effect. Where is the electron density? Where are we deficient of electrons? So in order to do that, we want to take our diene and show the resonance structure. I can move electrons from that donating group, the oxygen, and move those electrons over to this carbon right here. And on my dienophile, I can move the electron density over towards the oxygen. Circle the charges here so we don't confuse those for something else. And if I were to number my carbons, just the ones that are going to be in the ring of my Diels Alder product, 1, 2, 3, 4, 5, 6. And I were to number them down here, 1, 2, 3, 4, 5, 6. What we notice is that carbon 1 has a negative charge in the resonance structure, carbon 5 has a positive. So it makes sense when the Diels Alder reaction occurs, it's going to be 1 to 5 and 4 to 6. So again, if I were to number these in the ring, I would have 1, 2, 3, 4, 5, and then this one would actually be 6, where 1 bonds to 5 and 4 bonds to 6. Whereas the other product, the less favored product, would be the one where 4 bonds to 5 and 1 bonds to 6. That's least likely to happen because, again, looking at our resonance structures, we can see that the electron density of the diene is kind of focused there on carbon that I numbered 1, and we're electron deficient in carbon 5. So that's most likely the first bond that will form, and then 6 would bond to 4. So when we look at our substitution pattern for our potential products, it's going to be one of these 4 is most likely our major product. The next thing we need to look at in part 3 will be the endo-exo rule. Is my electron withdrawing group going to match those 2 methyl groups, or is it going to be opposite of those methyl groups? And again, for that, we're going to look at what is known as the endo-exo rule.